The age of space industrialization. As we all know, the resources of the universe are countless times richer than those of the Earth, but today, 60 years after the launch of the first man-made satellite, all human space activities rely on Earth's materials to be manufactured on the ground and launched from the ground into space. This is obviously still very primitive and unreasonable, and even more expensive and inconvenient. Only space industrialization can turn the romantic and magnificent science fiction scenario into reality, which is crucial to the future of mankind. Space industrialization has two key elements: 1. Space manufacturing, and 2. Extraterrestrial resources utilization. In space manufacturing, human beings have metallurgy, protein crystals, semiconductor materials production, space 3D printing and other preliminary experiments. The use of extraterrestrial resources is still relatively blank. The Moon and near-Earth asteroids are the basis for starting the real space industrialization. And this stage of the opening of the symbol, I think, is the construction of extraterrestrial materials, practical, commercial spacecraft or facilities such as lunar base construction, rather than small-scale experimental. To do this requires lunar bases or near-Earth asteroid capture/redirection technologies. There has been a lot of research in this area, and there are private companies working on NEO resources, and the relevant legislation has been improved. After reaching the sixth stage, which is space economization, space industrialization will be realized soon. The significance of this stage is that first of all, space manufacturing and space resources utilization will further reduce the cost of space applications, and at the same time make the dream that previously wanted to do but could not, such as space-based solar power stations, a reality. This is a supergiant satellite, with an area of more than a dozen or even dozens of square kilometers of solar power system, electricity output in gigawatts, 1 gigawatt equal 1000 megawatts, through the transmission efficiency of about 60% of the microwave beam radio transmission to the ground. The technical threshold for bringing clean energy from space is relatively lower than that of controlled fusion power generation, and as long as space industrialization can be realized, it is not difficult to make such a huge thing with the help of materials from the Moon and near-Earth asteroids. In addition, there is a growing shortage of some resources on Earth, such as certain rare earth materials, especially indium, which is inseparable from touchscreens. Only space industrialization can substantially solve the problem of energy and resource scarcity on Earth, which also helps the peaceful development of human beings and avoids conflicts caused by competition for resources under the scarcity of resources. High-quality materials from space, such as high-performance semiconductors and high-performance alloys, will also further improve the quality of human life. The resources from extraterrestrial bodies will also allow mankind to build giant spacecraft and space stations, which were previously only in science fiction, and make 2001 Space Rover and Access a reality, laying the foundation for the next stage. Until 2020, human exploration of Mars was limited to unmanned exploration using rovers, and in 2025, the Manned Mars program begins, and mankind takes its first real step toward the Red Planet. All of this is possible thanks to the good news that ExoMars is sending back from Mars. In 2019, ExoMars landed on the surface of Mars near Marvos Valley and began its roving exploration. Like the Curiosity rover, ExoMars will be able to collect rock samples from the surface of Mars and analyze them for possible organic molecules. After more than 2 years of exploring Mars, in March 2020, ESA and the Russian Federal Space Agency jointly announced that ExoMars had found crucial evidence for the presence of organic matter on Mars and that the probability of ancient life on the Red Planet has increased significantly. As soon as the news came out, the whole world was immediately stirred, and the enthusiasm of human exploration of Mars was exceptionally high. The Red Storm project is launched. On January 1, 2025, the United States, Russia, ESA 20, Canada, China, Japan, India, Israel, 27 countries jointly announced the launch of the first manned plan to Mars, codename Red Storm. Mankind will land on Mars in 2037. An international cooperation of this magnitude is unprecedented, with the United Nations Committee on the Peaceful Uses of Outer Space, COPUOS, coordinating the efforts of space agencies. The cost of a manned mission to Mars is so great that it would be a drag on the economy if it were left to one country, so an international partnership to launch a manned mission to Mars would indeed share the cost and reduce the risk. After repeated discussions, the countries finally decided to adopt the most conservative plan to send humans to Mars. First, a heavy-lift launch vehicle would be used to send the various components of the spacecraft to near-Earth orbit. Then complete the assembly of the spacecraft in NEO, then depart from NEO to Mars. Once in orbit, the astronauts will be separated from the spacecraft to prepare for a soft landing on the Martian surface. After landing, astronauts will spend nearly a year exploring and experimenting on Mars. After Mars exploration, the astronauts will return to their ship in an ascent vehicle parked in orbit around Mars. The spacecraft departs from Mars orbit and begins its return to Earth. After approaching Earth, the astronauts enter another landing module and return to the Earth's surface, ending the mission. After determining the manned Mars program, the countries have been working intensively on specific research and manufacturing work. After 6 launches of the SLS rocket, a nearly 500-ton, hydrogen-oxygen-fueled propulsion ship was assembled in near-Earth orbit. On January 6, 2037, the last SLS rocket, carrying 4 astronauts and a live aboard, was launched and docked with the ship in near-Earth orbit. After completing final commissioning, the spacecraft ignited and departed the blue planet, heading for the red planet in the distance. Human landing on Mars. Everything went according to plan, and on July 22, 2037, after several orbital changes, the ship finally entered its 500 km orbit around Mars. Soon after, 3 astronauts entered the landing module and separated from the ship, leaving 1 astronaut to work inside the ship. On July 23, the landing module broke through the Martian atmosphere and finally landed in the Amantis region, 23.27 degrees north 109.08 degrees east, on the edge of the Martian utopian plain, a day when the footprints of mankind were finally set on the red planet. The astronauts spent most of the 300-plus days of the Mars exploration in the life support module. They have completed numerous experiments inside, including testing the growth of plants and microorganisms in the Martian environment, converting carbon dioxide to oxygen in the Martian atmosphere, and smelting metals in Martian soil. Due to the limitation of the oxygen storage capacity of the spacesuit, the astronauts can only go to places close to the landing site during the extravehicular activity, which usually lasts about 6 hours. On May 19, 2038, after completing all scheduled missions, astronauts will depart the surface of Mars in an ascender and dock with the spacecraft parked in orbit around the planet. On February 8, 2039, the astronauts landed on the Earth's surface, and the Red Wind manned mission to Mars was a success. Breakdown of international cooperation. The success of the Red Wind program gave people on Earth new hope for Mars exploration, and many believed that the Mars exploration boom would begin and that the next manned missions to Mars would be launched within a few years. However, the international political situation is changing so that all of this is in vain. The countries involved in the manned mission had serious disagreements about the distribution of Mars samples and the sharing of manned mission technology. Space industrialization. In the 30 years since the first manned mission to Mars, only a few countries have launched unmanned probes to Mars, and the spacefaring nations have focused their development on the direction of space industrialization. Due to the high entry threshold of the aerospace field, the initial investment is huge. Without national support, the initial establishment of the company is difficult to be competitive. Therefore, countries are supporting their own established aerospace companies, hoping to develop outer space into a hotbed of economic growth for their own countries. In the process of space industrialization, a number of industries have gradually developed, including space transportation industry. Space transportation industry, developed from the early space launch industry, gradually developed into heaven and earth transportation, Earth low orbit, Earth orbit transportation, low orbit high orbit, Earth orbit moon, interplanetary transportation, Earth orbit asteroid/Mars, etc. Space communication industry, developed from the early satellite industry, gradually developed into Earth communication, Earth satellite Earth, Earth-Moon communication, Earth satellite Moon, interplanetary communication, Earth satellite asteroids/Mars, etc. Space tourism industry, from the early development of suborbital tourism, gradually developed into suborbital tourism, orbital tourism, lunar tourism, etc. Space energy industry, an emerging industry developed in the 1920s, mainly providing fuel supply for in-orbit satellites and detectors in the early stage, and later expanded to asteroid fuel production. Space mining industry, an emerging industry established at the same time as the space energy industry, based on asteroid development, mainly including mining and smelting of ores, covering iron, nickel, cobalt, platinum group metals, semiconductor elements, etc. Space manufacturing industry, based on the space energy industry and the space mining industry, it is mainly engaged in the manufacturing of products under microgravity conditions. Space factories have been built on the surface of asteroids, the orbit of the Earth, and the surface of the Moon, and most of the products produced are used for the establishment of infrastructure in space, and a small amount of products will be shipped back to Earth. The establishment of the Space Business Consortium. Under the influence of the space industrialization wave, many aerospace companies and space enterprises have sprung up. Whether it is LEO, GEO, lunar orbit, asteroid orbit, or the surface of the Moon and asteroids, there is a huge commercial development value. Due to the unique nature of the space industry, which is characterized by huge profits, huge investment and high risks, space companies in the same field have formed their own chambers of commerce to share the costs and jointly develop the space market with huge potential. The major space chambers include the following. United Launch Alliance, ULA, originally a joint venture founded by Lockheed Martin and Boeing in 2006, ULA was joined by a number of new space transportation companies when the wave of space industrialization arrived, focusing on space and space transportation and Earth orbital transportation. The main focus of ULA's business is on space transportation and Earth orbital transportation. The Universal Telecommunications Satellite Organization, UNISAT, consists of Intelsat, Inmarsat, Eutelsat, and AsiaSat. UNISAT is the result of the gradual merger of Intelsat, Inmarsat, Eutelsat, and AsiaSat, which encompasses the entire space communications industry and virtually monopolizes the Earth communications market. United Asteroid Institution, UAI, consists of planetary recesses, SpaceX asteroids, deep space. The UAI is a combination of planetary recesses, SpaceX asteroids, deep space industry, and near-Earth asteroid mining, NEA's mining, and later merged with some new space mining companies, basically monopolizing the market of asteroid mining, asteroid fuel production, and asteroid product manufacturing. Orbital Travel Agency, Orbita, by Virgin Galactic, Cosmic Exploration Company, SpaceX Travel, SpaceX Tourists, merged to form, mainly to develop suborbital, near-Earth orbital tourism, near-Earth space station tourism, etc. The cold shoulder of manned Mars exploration. The 1930s and 1960s were an era of corporate-driven space development. The first manned mission to Mars was a success, but after international cooperation broke down, the hundreds of billions of dollars spent on the journey was too much for any one nation to easily afford. The short-term value of Mars development is extremely low compared to near-Earth asteroid development. There are no scarce minerals on Mars, and a trip to Mars consumes much more fuel than a trip to an asteroid. Therefore, for the past 30 years, the Red Planet has remained untouched, with the occasional robot on a scientific mission landing alone on the surface of Mars and working until the last moment of stalling. The only chance to get up close and personal with Mars is the Orbital Tourism Board's Mars Orbital Tour, which takes 200 days to reach Mars orbit from Earth and 200 days to return to Earth after looking down at its beauty from space. The price of this tour is extremely expensive, the average rich people cannot afford. The tour spans nearly 2 years, with only 5% of the time spent in Mars orbit and the rest of the time spent in space. Such a long time in space life, the average person cannot afford. In the end, only one couple from the United States ordered the trip, and they became the closest people to Mars in the past few decades. Human landing on Mars. Everything went according to plan, and on July 22, 2037, after several orbital changes, the spacecraft finally entered its 500 km orbit around Mars. Soon after, 3 astronauts entered the landing module and separated from the ship, leaving 1 astronaut to work inside the ship. On July 23, the landing module broke through the Martian atmosphere and finally landed in the Amontis region, 23.27 degrees north 109.08 degrees east, on the edge of the Martian utopian plain, a day when human footprints were finally made on the red planet. The astronauts spent most of the 300 days of exploration on Mars in the life support module. They have completed numerous experiments inside, including testing the growth of plants and microorganisms in the Martian environment, the conversion of carbon dioxide into oxygen in the Martian atmosphere, and metal smelting experiments in Martian soil. Due to the limitation of the oxygen storage capacity of the spacesuit, the astronauts can only go to places close to the landing site during the extravehicular activity, which usually lasts about 6 hours. On May 19, 2038, after completing all scheduled missions, astronauts will depart the surface of Mars in an ascender and dock with a spacecraft parked in orbit around the planet. On February 8, 2039, the astronauts landed on the Earth's surface, and the Red Wind manned mission to Mars was a success. The breakdown of international cooperation. The success of the Red Wind program gave people on Earth new hope for Mars exploration, and many believed that the Mars exploration boom would begin and that the next manned missions to Mars would be launched within a few years. However, the international political situation is changing so that all of this is in vain. The countries involved in the manned mission had serious disagreements about the distribution of Mars samples and the sharing of manned mission technology. Space industrialization. In the 30 years since the first manned mission to Mars, only a few countries have launched unmanned probes to Mars, and the spacefaring nations have focused their development on the direction of space industrialization. Due to the high entry threshold of the aerospace field, the initial investment is huge. Without national support, the initial establishment of the company is difficult to be competitive. Therefore, countries are supporting their own established aerospace companies, hoping to develop outer space into a hotbed of economic growth for their own countries. In the process of space industrialization, a number of industries have gradually developed, including space transportation industry. Space transportation industry, developed from the early space launch industry, gradually developed into heaven and earth transportation, Earth low orbit, Earth orbit transportation, low orbit high orbit, Earth orbit moon, interplanetary transportation, Earth orbit asteroid/Mars, etc. Space communication industry, developed from the early satellite industry, gradually developed into Earth communication, Earth satellite Earth, Earth moon communication, Earth satellite moon, interplanetary communication, Earth satellite asteroid/Mars, etc. Space tourism industry, from the early development of suborbital tourism, gradually developed into suborbital tourism, orbital tourism, lunar tourism, etc. Space energy industry. Space energy industry, the emerging industry developed in the 1920s of the 21st century, mainly to provide fuel supply for in-orbit satellites and detectors in the early days, and later expanded to asteroid fuel production. Space mining industry, an emerging industry established at the same time as the space energy industry, based on asteroid development, mainly including mining and smelting of ores, covering iron, nickel, cobalt, platinum group metals, semiconductor elements, etc. Space manufacturing industry, based on the space energy industry and the space mining industry, it is mainly engaged in the manufacturing of products under microgravity conditions. Space factories have been built on the surface of asteroids, the orbit of the Earth, and the surface of the Moon, and most of the products produced are used for the establishment of infrastructure in space, and a small amount of products will be shipped back to Earth. The establishment of the Space Business Consortium. Under the influence of the space industrialization wave, many aerospace companies and space enterprises have sprung up. Whether it is LEO, GEO, lunar orbit, asteroid orbit, or the surface of the Moon and asteroids, there is a huge commercial development value. Due to the unique nature of the space industry, which is characterized by huge profits, huge investment and high risks, space companies in the same field have formed their own chambers of commerce to share the costs and jointly develop the space market with huge potential. The major space chambers include the following. United Launch Alliance, ULA, originally a joint venture founded by Lockheed Martin and Boeing in 2006, ULA was joined by a number of new space transportation companies when the wave of space industrialization arrived, focusing on space and space transportation and Earth orbital transportation. The main businesses are space transportation and Earth orbit transportation. The Universal Telecommunications Satellite Organization, UNISAT, is a merger of Intelsat, Inmarsat, Eutelsat, and AsiaSat. UNISAT is the result of the gradual merger of Intelsat, Inmarsat, Eutelsat, and AsiaSat, which encompasses the entire space communications industry and virtually monopolizes the Earth communications market. United Asteroid Institution, UAI, consists of planetary recesses, SpaceX asteroids, deep space. The UAI is a combination of planetary recesses, SpaceX asteroids, deep space industry, and near-Earth asteroid mining, NEAS mining, and later merged with some new space mining companies, basically monopolizing the market of asteroid mining, asteroid fuel production, and asteroid product manufacturing. Orbital Travel Agency, Orbita, by Virgin Galactic, Cosmic Exploration Company, Cosmic Exploration Company, SpaceX Travel, SpaceX Tourists, merged to form, mainly to develop suborbital, near-Earth orbital tourism, near-Earth space station tourism, etc. The coldness of manned Mars exploration. The 1930s and 1960s were an era of corporate-driven space development. The first manned mission to Mars was a success, but after international cooperation broke down, the hundreds of billions of dollars spent on the journey was too much for any one nation to easily afford. The short-term value of Mars development is extremely low compared to near-Earth asteroid development. There are no scarce minerals on Mars, and a trip to Mars consumes much more fuel than a trip to an asteroid. Therefore, for the past 30 years, the red planet has remained untouched, with the occasional robot on a scientific mission landing alone on the surface of Mars and working until the last moment of stalling. The only chance to get up close and personal with Mars is the Orbital Tourism Board's Mars Orbital Tour, which takes 200 days to reach Mars orbit from Earth and 200 days to return to Earth after looking down at its beauty from space. The price of this tour is extremely expensive, the average rich people cannot afford. The tour spans nearly 2 years, with only 5% of the time spent in Mars orbit and the rest of the time spent in space. Such a long time in space life, the average person cannot afford. In the end, only one couple from the United States ordered the trip, and they became the closest people to Mars in the last few decades. Subsequent impacts of space industrialization. The wave of space industrialization that has lasted for nearly 30 years has largely changed the face of the world. Space chambers of commerce, formed by space companies in the same field, not only control the lifeblood of human society economically, but also influence the political landscape of the entire world. The space industry is slowly transforming itself from a wealthy economic entity into a truly influential political entity, although its political status is not yet widely recognized by traditional states and international law, but most believe that such recognition is only a matter of time. In addition, the impact of the industrialization of space on human society includes rapid development of aerospace technology. In the first half of the 21st century, aerospace was still synonymous with high technology, high investment, and high risk for most people. The high cost of rocket launch and the delay in the practical application of new rocket engines made people feel that space was so far away from us. However, in the 1920s, with the gradual opening of the aerospace market, some private companies gradually participated in the competition of the launch market, and their reusable technology developed to minimize the cost of the aerospace low-cost. Reusable technology can be said to have moved towards the aerospace low-cost, reusable technology, and reusable technology. The first step toward low-cost and reusability of the aerospace industry, and the prelude to the industrialization of space. After this, the cost of spaceflight will gradually decrease and the competition in the space market will become increasingly intense. In order to occupy a place in this market, in addition to warming up with the space chambers of commerce that have been formed, we must continue to develop leading-edge spaceflight technologies to ensure that we will not be eliminated. In this sense, the rapid development of aerospace technology has not only brought vitality to space enterprises, but also accelerated the pace of the entire human society towards space. These new aerospace technologies include space fuel resupply technologies, space laser communication technology, space 3D printing technology, closed environment ecosphere technology, microgravity environment fabrication technology, near-Earth orbit electromagnetic projection technology, high-thrust ion engine technology, asteroid mining technology, asteroid hydrogen-oxygen fuel production technology. Near-Earth space market is exhausted. Near-Earth space does not refer to the space in low Earth orbit, LEO. The narrow definition of near-Earth space refers to the space within the Earth's sphere of influence, including near-Earth orbit, geosynchronous orbit, and the space within the Moon. The broad definition of near-Earth space also includes the space near the near-Earth asteroids, the Earth-Sun Lagrangian L1, L2, L4, and L5 points. Although there are countless resources in near-Earth space, there are still very few of them that have real commercial exploitation value. First of all, there are abundant helium-3 resources on the lunar surface, but since helium-3 is evenly distributed in the surface lunar soil, it is very difficult to mine and extract, and human beings have not yet mastered the mature nuclear fusion technology, so lunar helium-3 resources are out of reach for the time being. The developed neo-asteroids are mainly water-rich C-type asteroids and M-type asteroids with richer metal content, but not all C-type and S-type asteroids have development value. Since the orbits of neo-asteroids around the Sun are similar to the orbit of the Earth, this also means that the convergence period with the Earth is longer, that is, for a specific asteroid, it needs to wait for a longer time before it can meet a launch window or a return window, which makes space mining more difficult. Considering these factors, the market for near-Earth space is still very limited. By the end of the 1950s, almost all of the 200 or so asteroids that were profitable with the technology available at the time were already in the hands of their owners. The spread of pan-Mars thinking. Just as the Moon was untouched for more than 50 years after the success of the Apollo project, Mars has remained untouched for more than 30 years after the success of the Red Wind project, and history has played a great joke on Earthlings with its striking similarities. Earthlings have generally adopted two opposing views on the industrialization of space. One view is that the industrialization of space has led to the rapid development of aerospace technology, while also allowing humans around the world to feel the benefits of space, and that humans are moving step by step into the vast expanse of space. The other view is that the industrialization of space has given rise to one after another rich, political space chambers, which monopolize all aspects of space, but have always limited the scope of development to near-Earth space. The industrialization of space has essentially impeded mankind's progress into space, with deep space exploration falling by the wayside and Martian immigration nowhere to be seen. Initially, the two views were at odds with each other, but in the later stages of industrialization, the second view was more widely shared by Earthlings, and was called the pan-Mars mindset, which called for breaking the monopoly of the space chambers on commercial space development and called for an early start of human migration to Mars. The formation of the United Planet Institution, UPI. In 2060, the UAI, United Asteroids, announced its future development blueprint, announcing that it would expand its field of development to Mars. In 2060, UAI, United Asteroids, announced its future development plan, announcing that it would expand its development field to Mars, build the first human colony on Mars, and develop related Martian industries. In the same year, UAI announced that it would change its name to UPI, United Planet Institution, and claimed that the Mars migration program was in the preparation stage. Even UPI, which already has more than 100 asteroids in its possession, does not dare to act recklessly when it comes to the issue of Mars immigration. Even though UPI has used its political influence to gain the support of several permanent members of the United Nations through some hidden means, it is not easy for UPI to convince the general public of its blueprint for Mars immigration. The UPI has been in a crisis of trust because it has not been easy to convince the general public of its blueprint for immigration to Mars. Establishment of the Interplanetary Immigration Agency, IIA. On July 23, 2062, the 35th anniversary of the landing on Mars, the United Nations announced the creation of the first official interplanetary immigration agency in human history, Interplanetary Immigration Agency. Formally, the IIA is a subordinate agency of the United Nations and is responsible for coordinating human interplanetary migration. At the moment, of course, it is mainly responsible for Mars migration, which includes recruiting, selecting, and training Mars migration volunteers, conducting research on Mars migration-related technologies, and providing funding, technology, tools, and supplies during the initial migration process, and even including research on the transformation of the Martian ecology. According to the UN statement, the main source of funding for the IIA is the budget allocated by member states, with a small amount of funding coming from the Space Chamber of Commerce, but in reality, almost all of the IIA's financial assistance and technical support is provided by UPI, which is only using the UN brand to win the trust of Earthlings. In the eyes of many Earthlings, the IIA has even become a towering counterpart to the UPI, which has increased Earthlings' confidence in the IIA's proposed Mars immigration program. Mars Migration Program launched. After the establishment of the IIA, the Mars Migration Program was launched. According to IIA's idea, the first phase of Mars migration will be realized in 3 steps. The first human colony will be built on Mars in 50 years. According to the size of the colony, the construction phase will be divided into Mars Outpost, Mars Base, Mars City. The construction of other colonies and the ecological transformation of Mars will not be considered until the first stage is completed. Selection of the first Mars migration volunteers. After the launch of the migration program, the IIA announced the first batch of Mars migration volunteers, which attracted worldwide attention. The first group of volunteers will be recruited as 60 people and will be divided into 4 teams to be sent to Mars colonies. The recruitment requirements include age 18 to 40 years old, physically strong and mentally fit, possessing at least one professional skill or knowledge, and mastering at least one foreign language. It is worth mentioning that the IIA explicitly states in the recruitment requirements that immigrant volunteers must not return to Earth and must not have children within 50 years of the first phase. According to IIA officials, no return to Earth is allowed because it would cost additional funds during the colony building phase, and no childbirth is allowed because of the potential adverse effects of radiation on the surface of Mars on fetuses and pregnant women. Although the recruitment notice contained a stringent condition, it did not stop the people of Earth from applying, and the desire for the red planet was completely ignited on the blue planet. Most of the applicants are young people under the age of 30, who may have only recently entered society and do not yet have a happy family on Earth, thus saving a lot of worries about their families and looking forward to burning their youth on Mars. Of course, the IIA does not only select young people, but the entire immigration team also needs experienced people to guide the way. Therefore, some astronauts who have worked in space will also be selected to join the team of immigration volunteers. After more than a year of selection, 60 volunteers, 36 men and 24 women, from around the world were chosen. Of these, 40 were under the age of 30, 12 were between 30 and 35, and the remaining 8 were under 40, the age they will be in 2062 when they sign up. After 6 years of training, they left Earth for Mars on August 5, 2069. Pre-colonization preparation. In parallel with the recruitment of volunteers for Mars immigration, the IIA also began preparations for colony construction. At the time of the asteroid mining boom, UAI has built 2 electromagnetic projectors on LEO, which are charged with solar energy and are capable of projecting/receiving asteroid orbits NEO and NEO ground. The electromagnetic projector also uses a high-thrust ion engine for its own orbit maintenance. However, the electromagnetic projector cannot project everything, and due to the extreme overload during projection, it cannot be used for manned transport, but only for cargo. In addition, cargo must be transported in a specialized power projection module because the sensitivity of changing the spacecraft's trajectory is so high that it is nearly impossible to accurately deliver unpowered cargo to its intended location, while the power projection module is equipped with ion engines that can make orbital corrections while underway so that it can carry out cargo missions. IIA will first deliver an electromagnetic projector to Mars orbit to receive Earth-delivered cargo. On the other hand, sophisticated modules, instruments, robots, etc. will be transported on hydrogen-oxygen-consuming cargo ships that will be refueled at asteroid fueling stations. Before the official departure of the Mars settlers, there will be a lot of cargo and modules delivered from Earth near the landing site, including life modules, nuclear modules, plant modules, medical modules, food, water, rovers, robots, etc. Mars migration landing. On April 22, 2070, 15 members of the first Mars Migration Volunteers Expedition 1 landed in the northwest part of the Isthmian Plain, 16.181 degrees north, 84.624 degrees east, and a new chapter of humanity began. Mars colony construction. The construction of Mars colonies is not simply a development of the Martian surface, but a joint advancement of the Martian surface, the orbit, the asteroid industry, and the Earth's space industry, in a sense, a cooperative effort of the major space business associations. During the early construction, the asteroid industry, the space transportation industry, and the construction of Mars were developed in almost perfect harmony, especially the development of the space transportation industry, which provided a strong backup for the construction of the Mars colony. Early stages of construction. After the first outpost of the United Planets, UPI, formerly United Asteroids, or UAI, on the surface of Mars was established in April 2070 in I-City, the infrastructure was not perfect and life on the surface was basically minimal. These pioneers worked hard to build the colony in a hostile environment, and their feats led to the subsequent prosperity of Mars. The following year, other commercial consortia, including the United Launch Alliance, ULA, UNISAT, and the newly developed Promotion of New Propulsion Technology, PNPT, quickly joined in the construction of Mars colonies. At one point in 2075, ULA, UNISAT, and PNPT were providing 12 large spacecraft and space facilities around Mars. These space facilities have their own missions, from energy supply to space transportation, from mechanical maintenance to life support. They form a solid backup for the entire Mars colony. As the Martian colony is gradually being improved, many large facilities are being transferred from orbit to the Martian surface. It is worth mentioning that the satellite system provided by UNISAT, including meteorological satellites, positioning systems, and remote sensing satellites, has facilitated the construction of colonies on the surface of Mars. Earth-Mars transportation. The transportation of materials between Earth and Mars was once the most expensive part of the Mars Open Access program, and it was one of the most expensive problems for IIA's R&D department. In 2075, the PNPT was officially incorporated into IIA, and the space transportation industry reached its peak in the next 20 years. After a brief period of traditional chemical rocket propulsion, thermonuclear and ion propulsion rapidly emerged, making the Earth-Mars route faster and safer. Energy supply. Solar power was used extensively in the early years of Mars colony construction because solar power stations could be built quickly and at low cost. The first was the space-based solar power station, Helios I, which not only provided energy to the orbiting spacecraft, but also transmitted it wirelessly for terrestrial use. The second solar power station, the first terrestrial station, began construction as soon as the ground colony was settled and was completed in just a few days. The dust storms of the Martian spring and fall severely affected the efficiency of the solar power station, and the IIA decided to build a wind power station and a nuclear power station. By 2080, the Mars colony will have an energy supply based on nuclear power, supplemented by wind and solar power. Orbit around Mars. Prior to 2071, the only satellites in orbit around Mars will be remote sensing and communication satellites provided by UNISAT. In order to support the space transportation system and the construction of ground colonies, UNISAT has added several Mars satellites. In addition, ULA and IIA jointly launched the Mars Space Station, and other supporting facilities are gradually established. Remote sensing satellites provide early warning predictions of catastrophic weather on the surface of Mars, allowing ground construction to avoid bad weather conditions. The space station mainly serves as a space transportation cargo transit during the construction period. Ground construction. The first ground processing plant for the Mars colony was the fuel plant, which was already in operation before the arrival of the first Martian pioneers. After the outposts were established, the fuel plant was expanded, and by 2075 it was largely capable of meeting the fuel requirements for transportation between the Martian surface and the orbit around Mars. Using liquid hydrogen from UPI's asteroid mine, combined with carbon dioxide from the Martian atmosphere, the fuel plant can produce methane, oxygen, and alcohols. The majority of the liquid fuel is used for transportation between the Martian surface and orbit, with the exception of a small portion for surface vehicles. With the improvement of surface facilities, surface mines came into operation, but due to raw material and energy constraints, the mining industry only served the construction of the Martian colony. In conjunction with large power stations, fuel plants, air plants, and water plants, other backup living facilities were also established. With the establishment of large greenhouses, the ground colonies were able to accommodate more and more people, and the pace of construction was greatly accelerated, even as industrial chains of transportation, mining, smelting, chemicals, and manufacturing were quickly established. The main source of materials changed from the initial asteroid mines to the colony's factories. The manufacture of many machines, including architectural 3D printers, also became independent. In 2080, the Orbital Tourism Authority, Orbita, also began to invest heavily in the development of tourism on Mars colonies, and began to optimize the Martian transportation system. Some heavy industry companies, which originally focused only on Earth-based industries, also began to invest in Mars. With the core modules of the robots transported from Earth, the Mars colony has assembled several industrial robots, from material transportation to 3D printing of larger buildings, and the robots have greatly accelerated the pace of construction. Scientific exploration. During the construction period, scientific exploration on Mars was also thriving. Science in the early years of the construction period focused on archaeology, geology, agriculture, ecology, and physics, with Martian archaeology in particular becoming a scientific focus of almost universal interest. The development of Martian agriculture and ecology made possible the later large-scale ecosphere projects. The space station in orbit around Mars is gradually expanding as a base for researchers. As many of the thruster tests have chosen Earth-Mars orbits, some of the thruster research institutions have stationed researchers on Mars space stations, and UPI's Propulsion Technology Research Center has even set up a separate space station in Mars orbit to provide living and research space for its researchers. Interplanetary Communications Company, a key member of UNISAT, also has research centers on the surface and in orbit around Mars. Mars migration boom. The establishment of several large ecospheres has contributed to the first wave of immigration to Mars. Many businessmen and tycoons chose to retire to Mars, which has less gravity than Earth, to enjoy their time. Some young people think that Mars has a lot of opportunities for success during the construction period, and they are also striving to migrate to Mars to create their own future. In addition, because Mars offers many different environments from Earth, a large number of researchers from different research directions have chosen to live on Mars for a long time. The unique environment of Mars has rekindled many disciplines that were slow to develop, resulting in new research directions and more significant disciplinary crossover. In June 2102, UNISAT, ULA, Orbita, and UPI merged, retaining the UPI name. The merger of the four major chambers of commerce became a hot topic for everyone. With the merger, the investment in the construction of Mars colonies was greatly increased, attracting a large number of Earth-based companies to invest. The most prominent of these companies is Planetary Ecology, Incorporated. This was originally an Earth-based environmental company, but has invested heavily in research, including the development of small ecological loops. In 2113, the company was acquired by IIA, but retained its original corporate form. The following year, IIA split up some of its non-profit divisions and reorganized them into the Star Migration Center, with most of the R&D and service divisions becoming part of the Star Migration Center. The remainder was made up of mostly for-profit companies, which gradually became the economic source of the Star Immigration Center. During the Martian immigration boom, the IIA evolved from being financially supported by UPI to becoming an economically independent organization. Mars colonies become more sophisticated. The structure formed during the construction period of the Mars colony has been improved, forming 7 major industries: energy, mining, chemical, manufacturing, agriculture, transportation, and services. 1. Energy, nuclear power, solar energy, fuel. 2. Mining, mines, refining. 3. Chemical, fuels, materials, fertilizers, air, metallurgy. 4. Manufacturing, 3D printing. 5. Agriculture, plantation, bioengineering. 6. Transportation, rail transportation, highways, air transportation, airships, aircraft, heaven and earth transportation. 7. Services, tourism, communications, catering, medical, scientific research, culture. Some of the highly profitable industries have attracted many commercial companies, creating some high-paying jobs. The entry of commercial companies created a situation where some of the living quarters were made up entirely of workers from a single company. This situation gradually disappeared with the expansion of the colony. Orbital transportation was initially used only for industrial transportation, but as the population of Mars increased and several large ecospheres were established, orbital transportation became the primary means of transportation between large ecospheres. For air transportation, airships occupy a very important position. In the communications industry, interstellar communications became the largest provider of communications services on Mars, from terrestrial to interstellar communications, from hardware to software facilities, and from simple civilian communications to agency-classified communications. In the midst of the migration boom, interstellar communications has also established a second headquarters on Mars. However, there is no doubt that UPI has a virtual monopoly on the entire space industry. The Earth-Mars passenger transport system. The success of the orbital ejection system led to the creation of the interplanetary orbital accelerator between Earth and Mars. This allows spacecraft to be transferred from Earth orbit to Mars orbit with very little fuel, resulting in a significant increase in transportation costs and safety. The PNPT, a division of IIA R&D, has contributed significantly to the development of propulsion technology. Much of the research has successfully contributed to the spread of ion and nuclear propulsion, and has significantly reduced the cost of Mars immigration. Most of the immigrant spacecraft will transit at a staging area, switching from chemical to ion or nuclear-powered rockets. The IIA has documented that some of the stowaways were done through the Hohmann transport system. It is important to note that this is a very dangerous practice. In addition to the high system failure rate, the radiation exposure during the trip to Mars was much higher than normal passenger transport, and at one point IIA used extensive cargo monitoring systems to prevent stowaway behavior. Mars City development. After a brief period in the living quarters, the orbital spacecraft and ground engineering jointly established several small ecospheres which, in addition to serving as living quarters for the ground crew, were important experimental sites for the Mars terraforming project, the most notable early result being the use of Martian soil to grow a large number of plants. These small ecospheres are not a completely isolated system and require a lot of external supplies. Once propulsion technology was developed, travel from Earth to Mars became easier and faster, and many Martian outposts and bases were established. Many of the more powerful forces were eventually able to develop their bases into real Martian cities. However, after the boom and the economic crisis, this scattered enclave movement almost stopped and evolved into a race to expand around large cities and bases. Mars outposts, bases, and cities. Mars outposts are clusters of more than 100 people, Mars bases require more than 1,000 people, and Mars cities are clusters of more than 10,000 people. By 2200, Mars cities had grown to 11, and the neighboring cities were mutually beneficial, forming 4 larger urban areas. Due to the rapid emergence of Martian cities, the Martian tourism industry was also growing rapidly. The Isthmian City Circle. Since the first Martian colony was established on the Isthmian Plain in 2070, the colony grew in size to the size of a medium-sized city on Earth by the early 22nd century, and became known to people on Mars and Earth as Isthmian City I, or City I for short. Compared to IIA's initial plans for Mars immigration, City I was built much faster and on a much larger scale than expected. However, during the Martian immigration boom of the early 22nd century, the demand for immigrants on Earth gradually increased, and City I could no longer cope with the increasing influx of immigrants. Therefore, the construction of City 2 and City 3 was planned. Considering the convenience of transporting resources, the sites of both City No. 2 and City No. 3 were chosen to be located on the Iodai Plain. Almost all of the resources and sources used in the construction of these 2 cities came from City 1. After the 2 new cities were built, new settlers and many of the colonists from City 1 came in, and the 3 cities became very close to each other. 22 In the 1920s, the first prosperous city circle on Mars was gradually formed in I-City. On February 17, 2123, after a referendum of the colonists, the first, second and third cities were named after the 3 stars of the Winter Triangle, and were called Procyon City, Betelgeuse City and Sirius City. And Sirius City. Amazon City Circle. During the construction period of Betelgeuse and Sirius, the IIA was already planning to develop various resources on Mars. With the rapid increase of the Martian population, many young explorers are not satisfied with just living in the 3 feet of the Isthmian Plain. They would rather spend their youth to see all the wonders of the Red Planet, even if they leave the favorable conditions of the Martian cities and step into the untouched life zone. In addition, Martian archaeological and geological expeditions have also started throughout Mars, and these explorers have collected a lot of important data in the field, providing valuable information for resource exploration and research on the ancient ecology of Mars. To support explorers and prospectors, the IIA has set up small resupply stations around and on the way to some of the major sites on Mars. These resupply stations, usually consisting of 3 or 4 living modules and several storage modules, provide resting places for past inhabitants on this inhospitable planet, as well as supplies of water, food, energy, and fuel. By the middle of the 22nd century, the number of such supply stations had reached several hundred. Mount Elysium and Mount Olympus are among the most popular tourist and exploration sites on Mars. Because of the proximity to Ishii and the smoothness of the road, there are more people traveling to and from these 2 mountains, and the size of the supply depots in this area has increased. It was from the 2 Amazonian Plains supply depots that the 4th and 5th cities grew slowly. City 7 has a more recent history than City 4 and City 5. The terrain was complex and uneven, but the rich iron ore resources and low latitude made it an energy and mining town, and many machinery manufacturing companies chose to locate their plants in the city. In the 1950s, the Amazon City Circle, with cities 4, V, and 7 as the core, was initially established, and the local colonists named their cities after the ancient city-states of the Earth: Croran City, Pompeii City, and Atlantis City. Meridian City Circle. Prior to the establishment of City 7, some Mars-based companies began planning to invest in new cities in other parts of the planet. However, for reasons of funding and location, many of these new sites did not develop quickly and only reached the size of Mars bases, over 1,000 people and under 10,000 people, or were even built as Mars outposts, over 100 people and under 1,000 people. The Mars real estate industry, MREI, invested in the construction of City 6 in 2139, which was originally a small geological station. With the arrival of capital, many construction resources were airlifted from Iadai to City 6 by airship. In order to attract more people to move to City 6, MREI worked hard to design the city for convenience and comfort, and spared no expense in purchasing a number of rare earth plants and animals to make City 6 one of the most inhabited cities on Mars. In 2145, MREI named the city Singularity City when it was officially inaugurated and sent out commercial advertisements to other cities. Some people who were old and had small savings were attracted by the comfortable living conditions in Singularity and bought the real estate of MREI. While the population of Singularity was rising, in 2148, MREI started to build another city, Horizon City, on the southeast side of Singularity, on the other side of the meridian. The construction of Horizon City was accompanied by the construction of the Mars Space Elevator, which made Horizon City a very important transportation port. It was originally the only small starport on the Meridian Plateau, capable of delivering modest loads into near-fire orbit and receiving cargo from space. Vision was developed commercially in a similar fashion to Singularity and was finally completed in 2153. The Horizon Starport was also built as the largest starport on Mars at the time, with many incoming and outgoing cargoes transiting there. Due to MREI's commercial development of City 6, the original geological station had to be relocated. The former City 9 was moved to the new station at the mouth of the Kasai Gorge Valley in the Kreese Plain. As one of the largest outflow waterways on Mars, Kasai Gorge was likely formed by the massive flooding of Ikus Valley. Cass Canyon is important for studying the hydrology of Mars. Because of this, the IIA supported the construction of this new station, and within a few years it quickly grew into a larger geological institute, with many geologists moving their work to this site. In 2165, the Planetary Geology University was inaugurated on the site of the Geological Institute, and the city took shape. 2167, after a referendum, the city was named Bolide City for education and research. The Meridian City Circle was thus formed. The Greek City Circle. The Greek plain was rich in minerals and the water resources were much richer than in other low-latitude areas, so there were several outposts and even bases in the Greek plain from the beginning. The first city was founded on the basis of an outpost. By the time ExoMars established its outposts there, many of them had grown into larger bases. However, ExoMars developed a good relationship with the local base and established a partnership with Planetary Resources, and the outposts quickly grew to base size. ExoMars proposed a more open partnership with other organizations, which later became the Mars Trantopolis project, which began to integrate construction in 2155. ExoMars, Incorporated. ExoMars, Inc. is a Martian mining company. Its predecessor, Arc Resources Incorporated, was originally engaged in the asteroid mining industry, but in the midst of intense competition, the company's president, Ava, convinced everyone to shift their focus from asteroid mining to the Mars mining industry, with the industry focusing on Mars surface construction services. After a period of rapid growth, the company acquired several smaller Mars mining companies and changed its name to ExoMars, in honor of Ava's untimely death. In 2156, the year after construction began on Trantor, construction began on a city on the edge of the Greek plains, invested by the Interplanetary Migration Authority. The city was named Endpoint from the beginning because it was located on the edge of the Greek plain, and there was already a city of Trantor in the center of the Greek plain under construction at the beginning of the year. The city was designed as an agricultural city. Thanks to the development of technology and the influx of capital, the basic construction of the city took only 2 years. However, the construction of Kawartha, which started much earlier, was completed only 1 year after the completion of Tuan Dao City. Due to the late completion, Tuan Tao City was numbered as the 11th city and Tuan Point City was numbered as the 10th city. In 2168, the two cities decided to open up more reciprocal resources to form the Greek City Circle. Mars Earth Quarantine and Mars CDC. Early in the construction of Mars cities, Earth and Mars jointly established a quarantine system for Earth and Mars. This system includes not only the normal official quarantine work, but also the participation of commercial auditing companies. Since the conditions on Earth and Mars are different, all organisms brought from Earth to Mars need to undergo strict scrutiny. This part of the audit certification is done through companies. One of the more famous is Berlin Pioneer. However, because the genetically modified organisms specifically for Mars development all carry specific genes, each such organism expresses a protein that is thought to be designed to have no effect on the organism, but is easily detected. This has become an important technology for biosecurity on Mars and Earth. Berlin Pioneer. Berlin Pioneer, a company focused on biological audits for Mars-Earth transportation. The company is headquartered in Berlin, but has several offices and R&D centers around the world. The founder of Berlin Pioneer, Stefan Klein, was a student at the University of Munich in Germany when he designed a system to determine the impact of new species on existing ecology. With the subsequent rise of Mars migration, Stefan Klein began to design the safety of genetic modification of organisms on Mars. He proposed to add genes that produce specific proteins to all genetic modifications designed specifically for Mars, so that these Mars-specific organisms could be easily distinguished and detected. He then founded Klein Genetics, a company later renamed Berlin Pioneer, which grew to become the world's largest biological audit company in the 22nd century during the subsequent wave of Martian immigration. Many of the company's patents were related to genetic modification, and these patents generated huge profits for Berlin Pioneer. In 2207, during the construction of the Iadi urban area, a new type of infectious disease broke out in South River City due to the increase in human traffic. The outbreak was eventually brought under control when some residents of the South River City set up a temporary disease control center on their own initiative, but statistics later showed that 348 people died as a result of the disaster. The disease became known as idiopathic. Abby Carter. Abby Carter, a renowned neuroscientist who happened to be on vacation on Mars at the time, discovered that the Ishii virus exhibited a collective behavior. Although many people were infected with the virus before the outbreak, almost all of them became ill on the same day. This collective behavior later served as a model for the study of such infectious diseases and led to the establishment of the Mars Disease Control Agency. The ICIT's Centers for Disease Control and Prevention was renamed the MCDC, Martian Centers for Disease Control and Prevention, in 2209 and established MEPC, Martian Epidemic and Pandemic Control, which is responsible for monitoring and immediately announcing the tracking of pathogens on Mars, especially mutations of pathogens. In 2213, the Mars Health Organization, MO, Martian Health Organization, led by the Martian CDC, was established, and the Martian CDC was incorporated into the MO as a subordinate organization. The Moon is much closer to Earth than Mars is to Earth, yet the start of its large-scale development will be in 2039. After the first manned Mars program, large-scale multinational international cooperation stalled, but the European Space Agency, ESA, and the Chinese Aerospace Group, CA, have been pioneers in lunar development through extensive cooperation. In 2013, the Chang'e 3 and Yeta lunar rovers once again broke the lunar silence of many years, and in 2019, China's Chang'e 5 set foot on the Moon again, but by then the world's attention was on Mars. Lunar exploration continued slowly and steadily until 2036, when the Chinese Space Agency and the European Space Agency collaborated to establish an experimental lunar settlement on the Moon on the eve of the imminent landing. This was built using robotic 3D printing construction technology, using lunar soil in situ. This project was only used to test 3D printing technology outside the Earth. After the exploration of Mars, large-scale international cooperation broke down until 2039, when a second permanent settlement was established and both settlements were renovated, fitted with life support equipment and stocked with supplies for the first astronauts to follow. The following year, the first lunar astronauts moved into the second settlement. As a short-term test, the entire crew returned after 20 days and brought back the experimental data generated during the 20 days of habitation, which were analyzed by various experts and used for the improvement of the settlement. After several expert meetings, a number of improvements to the settlement were immediately implemented. In 2042, the first lunar research base, an extension of the first two settlements, was built. Several scientific projects, including lunar resource exploration, extraterrestrial astronomical observations, planetary science, gravitational wave detection, and other scientific research, are on the agenda. Chinese and European researchers are permanently stationed there. The new lunar environment has led to many scientific breakthroughs and an explosion of new articles in academic journals. The long-term settlement and research base operated so successfully that in 2049, the then China Aerospace Group, formed by the merger of China Aerospace Science and Technology Group and China Aerospace Science and Technology Group in 2041, established the first lunar resource mining base at Hengguan on the Moon, with the primary target being ilmenite in the basalt of Hengguan for use in lunar and space construction. The following year, near-Earth asteroid mining established rare earth resources and iron ore mining sites in the Storm Ocean. These two sites were so productive that a partnership was established between China Aerospace (NEAM) and SpaceX in 2051. In 2042, the China Aerospace Group started to build the first tourism center on the Moon, marking the official start of the Moon's civilization. Lunar tourism has also become a popular tourist attraction among the rich and famous. Space elevator. The construction of the space elevator has had many twists and turns. As early as the mid-20th century, there have been a variety of space elevator designs, and even a more complete design and feasibility study of the lunar space elevator. However, due to material constraints, the construction of space elevators has not been initiated until the perfection of the Martian city circle. The space elevator on Mars can become a reality. The first space elevator on Mars was born in the context of the completion of the I-City, Meridian, and Greek metropolitan areas in 2158, and the initial size of the Greek metropolitan area, when the bottleneck in transportation between Mars and space was realized. The elevator was proposed in 2156, and construction began only after 2 years of planning and research. It took 5 years for the project to be completed slowly, and the elevator was put into operation in 2163. The Mars Space Elevator successfully relieved the pressure between the Martian surface and space transportation, and significantly reduced transportation costs. The ground station was chosen next to the Vision City, whose construction began in 2148. During the construction of the space elevator, many of the production facilities in Vision City played a key role in providing the construction resources for the space elevator. This was followed by 4 major expansion and maintenance projects for the first space elevator, which greatly increased the transportation load. After the space elevator began operating, Vision City, which was originally a space transportation business, was completely transformed into a large spaceport city, called Vision Starport. With the experience of the first Martian space elevator, it took only 3 years to build the second space elevator, which was built for the convenience of the Isthmian City Ring, so the ground station was located not far to the south of the Isthmian City Ring. 2213 Star Migration proposed that Earth assist in the terraforming of Mars, but it did not receive an enthusiastic response. 2214 Space Elevator. The construction of the space elevator in 2214 was a further step in IMB's efforts to develop and terraform Mars. After the start of the Mars terraforming program, between 2223 and 2225, the construction of the third space elevator further accelerated the construction of Mars and prompted many forces to join the Mars terraforming effort. Due to the development of Mars and the initiation of the first phase of Mars terraforming, the transportation capacity between the surface of Mars and space could not fully satisfy the Mars construction needs. Therefore, between 2230 and 2234, 2 space elevators were built. The ground stations are located between the Isthmian and Meridian urban areas, and between the Isthmian and Amazonian urban areas, respectively. Space cities. The space industry has played a very important role in the emergence of space cities, and with the development of 3D printing, large solar panels, and increased space production capabilities, the construction cycle of space cities has been greatly reduced. Functional space station. Back in 2038, Made in Space and Silk Road Technologies partnered to begin construction of the Nico space station to test the feasibility of a functional space station in deep space. Construction accidents occurred, including one in 2039 in which 5 construction workers were killed, including 2 Space 3D printer operators. The station, originally planned to be completed in a year and a half, was not completed until early in the 3rd year after construction began. Although the construction of the Nico space station was fraught with hiccups, it laid the groundwork for later functional space stations, including solar-powered space stations, space mines, space processing plants, and more. The real explosion of functional space stations will occur in 2045. In 2045, a startup called Space Tech Life received investment from Planetary Resources for a comprehensive space station design called the Titan Star, sparking a boom in comprehensive giant space station designs. In 2046, Space Tech Life officially joined Planetary Resources to focus on space station development. Large Space Station. In 2044, Planetary Resources, a leader in the space mining industry, and Made in Space, a space 3D printing company, launched plans for the first small, 20-meter diameter rotating ring space station. In 2048, Planetary Resources' 200-meter diameter, 10-meter wide rotating space station factory begins, also in near-Earth orbit. The station was completed and tested for crew habitation in 2040. Both of these ring-shaped space stations were highly satisfactory in terms of their multifaceted metrics and served as models for future large space stations. Space cities. The stability of the large space station has inspired even more ambitious plans to build space cities. The first space city was designed in 2049, and construction began in 2050 as Falls City. In order to obtain more living space, a cylindrical design was adopted. The diameter reaches 1,000 meters, however, the length of the shaft is designed to be 500 meters, taking into account the stability issues. This is a cylindrical space city with closed ends, and multiple spokes are used to tighten the cylinder. The spokes are also equipped with elevators for quick access to the rest of the space city. After the construction of Starry Night City in 2053, a number of functional space stations were built in its vicinity, creating a functional ecosystem of space stations, but life on each station was not particularly desirable due to its small size and dispersed activity space. Dissatisfied with the management of Planetary Resources, Alan Gonzalez, founder of Space Tech Life, left Planetary Resources and founded Starry Space Construction in 2040 after completing the construction of Planetary Resources' 200-meter diameter space station. They designed a 2,000-meter diameter space city They designed a space city with a diameter of 2,000 meters and a 2-level structure, Starry Night City. The first level of Starry Night City is 1,500 meters in diameter, but instead of a full cylinder, this level consists of 3 1/6 cylindrical platforms. The entire station is constructed with 6 spokes, 3 of which pass through the first level of the platform. The construction period for Starry Night City is 2042 to 2046. Initial research on the terraforming of Mars. James B. Pollock and Carl Sagan collaborated on the study of the terraforming of Mars and its pathways as early as the late 20th century. The methods they proposed at that time became a major source of inspiration for later Mars terraforming projects. In the 1970s, shortly after construction of the Mars colony began, the Bureau of Interplanetary Migration asked the colony builders to prohibit the removal of potential biological sources from the exterior of the colony. With the exception of greenhouses and small indoor farms on Mars outposts, no plants could be planted anywhere. This was done to minimize the possible impact of Earth's primitive organisms on the ancient ecology of Mars, which could interfere with Martian eco-archaeological research. However, by the end of the 1980s, with the expansion of the colony and the completion of the surrounding eco-archaeological work, the planting ban was no longer necessary. The Bureau of Interplanetary Migration also began some preliminary research on plant and microbial genetic modification and outdoor planting experiments. The main focus of the research was on how to allow photosynthetic plants such as green algae to survive in the low temperature and low pressure environment of Mars. In the 1990s, the study of terraforming Mars has become a major focus of Mars research. However, due to the limitations of the Martian infrastructure and research facilities, these studies were not conducted on Mars, but on Earth. The Bureau of Interplanetary Migration has made data from various ecological and geological expeditions, atmospheric monitoring stations, meteorological satellites, and remote sensing satellites into open-source databases for scientists in related fields on Earth to conduct their research. Although far away from Earth, with the help of these massive data, scientists on Earth were able to build more accurate models of the Martian atmosphere, geology, etc. in a short period of time, just like being on Mars. In the 22nd century, the first wave of Martian immigrants arrived. The Bureau of Interplanetary Migration, BIM, also launched a talent attraction program for Martian researchers on Earth. They were promised advanced research facilities, real estate in the central city of Isthmus, and so on. These measures attracted a significant number of researchers to settle on Mars and continue their academic research. In 2125, 2 years after the official completion of the Isthmian urban ring, the Planetary University was founded in South River City. The first professors of the university were mainly Martian researchers who were brought from Earth. In the following decades, the university became a major research center for the terraforming of Mars. In contrast, related research on Earth has gradually fallen silent. The game on the eve of terraforming. Although Mars terraforming research started quite early, it was really implemented in the 23rd century. The reason is that, on the one hand, everyone realized through continuous research that for human beings, the terraforming of Mars is a mega project, and it is impossible to achieve results without hundreds of years of continuous sedimentation. On the other hand, major companies and chambers of commerce are too busy with the development of resources on Mars and asteroids and the expansion of their market shares to invest in the terraforming of Mars. For profit-oriented commercial companies, direct investment in Mars terraforming projects will not pay off for at least a century. This would be extremely fatal for them. However, in the long-term interest of Mars, terraforming is an essential step in the development of Martian civilization. Without a global habitable ecology, it is impossible for a few large, scattered enclosed cities to compete with Earth cities. The poor ecological environment of Mars has become an obstacle to its further progress. From the perspective of Earth, Mars is now in a relatively independent state. The relationship between the two planets is generally friendly and peaceful, there is no mutual hostility, and Earth has no desire to conquer Mars. However, the Earth has been uncooperative in terraforming Mars. This is to ensure that the absolute superiority of Earth civilization over Mars civilization is not broken. The terraforming of Mars could be an opportunity to upset the balance. On the other hand, many organizations that support planetary protection policies have given in to previous Mars development projects, but want to hold on to the last front of Martian ecological transformation. One such group is the Gaia Coalition, a very radical group that uses celebrity speeches and internet propaganda to warn people of the disasters of planetary transformation. Some people within the Gaia Coalition have even developed a religious belief in planetary Gaia, believing in the god of planetary Gaia and that the planets are sacred and cannot be violated. In the midst of intense external and internal conflict, a small group of people broke away from the Gaia Alliance, reinterpreted the original doctrine, and called Earth Gaia a ghostly Gaia, claiming to be the hand of Gaia. The new doctrine believes that human beings do not have free will, and that every life on Earth is merely an information carrier in the growth of the phantom Gaia. They believe that humans are part of the phantom Gaia, and that the transformation of Mars is only a means for the phantom Gaia to continue to grow. They themselves are the hands of the phantom Gaia, responsible for protecting the growth of Gaia. By the beginning of the 23rd century, the technical feasibility of terraforming Mars had been proven, and despite much pressure from outside, the Bureau of Interplanetary Migration decided to take the lead in funding commercial companies to bid for the terraforming project. Terraforming Phase 3. In 2213, the IMB made its first call to Earth to assist in the terraforming of Mars. Not surprisingly, all of Earth's major power groups and political institutions were passive and cooperative and took a wait-and-see attitude. After 2 years of negotiations, IMB received no technical support from Earth, nor did it convince any agency to provide financial support. The negotiations ended in total failure. In 2216, the Bureau of Interstellar Immigration announced its intention to cooperate with Earth for the second time, and made a lot of publicity and mobilization efforts, which were still met with a lukewarm response from all sides of Earth. However, in 2218, IMB launched the first phase of the Mars terraforming project with a number of companies. However, this was a long-term project led and fully invested by the IMB, with companies and chambers of commerce in related fields bidding for the project. After the previous experiments, IMB established a visionary project called Mars Homeland, which was completed through 3 phases. The themes of the 3 phases are atmospheric modification, vegetation establishment, and biodiversity. The first phase of the project uses a multi-pronged approach to atmospheric modification, including the production of greenhouse gases from Mars surface air plants, the release of greenhouse gases from Mars' own storage, and the transport of greenhouse gases from outside Mars, which are carried out simultaneously and complement each other. The second phase of the project uses genetically modified plants for the establishment of vegetation on the surface of Mars to create a very preliminary ecological loop. The third phase of the project is based on the results of multiple analogies for biodiversity. The first phase of the project was actually officially launched in 2219. After negotiations, the Titan Air Collection Station on Titan, the Water Ice Collection Station on Io, Callisto, and the Liquid Ammonia Synthesis Station on Titan began to be built on a large scale with the participation of ExoMars and Titan, Vatra and several small companies, and the Interplanetary Mass Transportation System in cooperation with UPI was built on the basis of previous experiments. At the same time, large hydrogen bombs designed by the Bureau of Interplanetary Migration and modified solar sails in orbit were used to release carbon dioxide and water vapor from the Martian polar caps, most of which were converted from solar sails previously used for material transportation. The first phase of the project took nearly 160 years to complete, with interruptions and program upgrades, but the initial transformation of the Martian atmosphere eventually met the original goals. The second phase of the project is gradually entering the main body of the project, which is led by Skypark and Azaegan. Although their core technologies are different, they have been proven to be safe and effective in practice for a long time. Prior to the completion of Phase I, GM plants were planted on a large scale in specific areas after laboratory safety validation and Mars simulated environment testing. By the middle and end of the second phase, in the early 25th century, people were breathing Martian air for short periods of time. In 2422, the Mars Ecological Replenishment Program was initiated, led by Azure Genetics, before Phase 2 was fully completed, and Phase 3 was only being implemented on a very small scale at that time. It was not until 2467 that the Biodiversity Program was officially launched on a large scale, and Phase 2 was officially completed 3 years prior, in 2464, by which time the Martian air was ready to breathe. At this point, the Rime ecology joined the project and began to play a key role. By 2462, the Martian air was approaching the health standards of the Bureau of Interplanetary Migration. By this time, several companies saw that terraforming had been largely successful and began to join the massive project. After 3 phases of the project, many biological companies joined forces to form specialized research departments, which provided many engineering solutions. After the 3 phases of the project, the complexity and stability of the Martian ecosystem was greatly increased. Titan development. Human interest in Titan, Titan's unique tourism resource, has been developed. After the IMB started the Mars Terraforming 3 project, the atmospheric and water resources on Titan were transported to Mars in a steady stream. These precious resources have nourished Mars for nearly 100 years, and have allowed Mars to gradually break away from its dependence on Earth and become an independent planetary polity. Early exploration of Titan. The early exploration of Titan dates back to the pre-industrial era of space. As early as 1979 AD, Pioneer 11 visited the Saturn system and sent back some photos. Voyager 1 and Voyager 2 flew past Titan in 1980 and 1981, but after a brief glimpse they each headed further into deep space. It was not until the Cassini-Huygens arrived on Mars on July 1, 2004, that mankind gradually unveiled this mysterious planet. The Huygens lander touched down on the surface of Titan on January 14, 2005, and in the process sent back a lot of data about the Titan atmosphere. The Cassini probe worked until 2017 when it was officially decommissioned. Thanks to the discovery of the Cassini probe, the Titan Mare Explorer, TIME, a Titan exploration mission that was halted due to lack of funding in the early days, was reintroduced to the development schedule. Composition of the ocean. But in this data, scientists found no trace of life in the ocean. In 2035, the NASA-developed Titan Deep Submersible Explorer, the Kraken, successfully explored Titan's deep ocean. But scientists regret that the Kraken still has not found any traces of life in the Titan Ocean. With mankind targeting near-Earth asteroids for space exploration, not enough attention has been paid to extrasolar, the solar system outside the asteroid belt, excluding the asteroid belt, exploration. Even though some routinely launched orbiters or landers visit these extrasolar targets every 10 years or so, no major scientific breakthroughs have been made in their exploration. Titan exploration has thus fallen silent. Development of the Titan tourism market. Until SpaceX travel was incorporated into the Orbital Tourism Authority in 2046, the association's primary travel markets were focused on near-Earth orbit and the Moon. Since then, however, the expanded Orbital Tourism Authority has launched ambitious plans to develop the near-Earth asteroid tourism and Mars orbital tourism markets. As it turns out, the development of the neo-asteroid tourism market has proven to be very successful, as these tours are short, inexpensive, and popular with young tourists. However, orbital travel around Fire is not so fortunate. Because of its long time period, over 2 years, and high cost, it is simply unaffordable for the average traveler. In the end, the tour was largely unappreciated. But by the 1980s, the first wave of Martian immigrants was beginning to emerge. The time required to transfer flights from Earth to Mars decreased as the ship's power systems improved and the time cost of traveling to Mars decreased, making Mars orbital tourism and even surface tourism more sought after by the wealthy on Earth. In the next decade or so, the Orbital Tourism Authority has gained huge profits from Mars tourism routes, and its plan to develop the outer solar system tourism market is also emerging, including the Jupiter Orbital Tour, including its main satellite, Saturn Orbital Tour, including its main satellite, 2 routes. Titan, with its unique atmosphere, methane oceans, and other natural features, has been the focus of publicity for the Saturn orbiter along with the magnificent rings of Saturn since its inception. In 2102, before the official launch of outer solar system tourism, the news of the merger of the 4 major chambers into the United Planets spread throughout the solar system. However, the enthusiasm for space travel did not wane, and the classic itineraries remained, with tours to Jupiter and Saturn also being launched. Although the Saturn system is more distant than the Jupiter system, the thick atmosphere on Titan ensures that the radiation levels on Titan are low. Of course, the scenery of the Saturn system is more eye-catching than the Jupiter system, and this tour was favored by more people. In those days, Mars cities were still small and not very populated, so most tourists to the outer solar system came from Earth rather than Mars. In 2158, as the first Mars space elevator was being built next to Vision City, a local Mars company dedicated to the development of Mars orbit and its satellites was founded in Vision City under the name Vertical. The smooth completion of the space elevator also put Vertical on the path to take off. Vertical was founded in 2158. According to the founder of Vertical, when he was naming his company, he looked at the space elevator under construction on the fire horizon in the distance and suddenly thought of the vertical and horizontal view of the sky after the elevator was completed in the future. Vertical, so the name was decided, and the company's logo is also made up of 2 lines, one vertical and one horizontal. In the 1970s, the company also introduced cheaper tours of the outer solar system for the citizens of Mars, including, of course, Titan tours. Saturn and Jupiter also became quite realistic destinations for the average Martian citizen. Extrasolar travel. Even in the 22nd century, traveling to the outer solar system is still a time-consuming and costly endeavor. It takes about 13 Earth years to fly from Mars to Saturn using the conventional home and transfer orbit, with a launch window every 2 years, and about 6 years to fly to Jupiter, with an additional launch window every 2 years. This was clearly not feasible. Even with the most advanced spacecraft of the time, it would have taken at least a year to fly to Saturn. Therefore, for the people of the time, whenever Saturn and Jupiter were closer together, known in astronomy as the Great Conjunction, there was a period of peak tourism to the outer solar system, which occurred every 19 to 20 years and lasted about 1 to 2 years. During this peak period, tour companies offer the Jupiter-Saturn route, JS route, which provides visitors with the opportunity to see the magnificent Jupiter and Saturn systems over a 3-year period. Exploitation of Titan's natural resources. Exploitation of Titan's natural resources has developed in tandem with the boom in tourism on Saturn, and in 2180, the JS route, first introduced by the Fire Spine Company, attracted many space-loving Martian adventurers. In response to this once in 20 years tourism boom, the company began expanding the satellite's visitor service centers in the 1970s, the two largest being the Europa, Io, Visitor Service Center and the Titan Visitor Service Center. These two visitor centers are fully equipped and large in scale, mainly using local resources for construction and maintenance. This is the beginning of the development of Titan resources. The Mars Terraforming 3 project is the catalyst for the development of Titan's natural resources. The atmosphere replenished by the terraforming of Mars is mainly from Titan. Titan migration. The visitor center on Titan is comparable to a new town on Mars, but the people living here are very mobile and do not live here for more than a month on average. Once the tourism gold rush of the early 1980s was over, the Titan Visitor Center lost a large portion of its foot traffic, leaving only the necessary number of workers, and the remaining Titan immigrants really got on with their lives. Compared to Mars, Titan's immigration conditions are much more difficult, but there are many bright spots that attract immigrants here. First of all, because of the distance from the Sun, Titan has been in low radiation levels. In this period of outdoor activities do not need a lot of radiation-related medical assistance like Mars, and do not need to carry out gene therapy transformation. Many people choose to come to Titan development, is out of such considerations. Secondly, many Martian immigrants are tired of the Gobi-like terrestrial environment of Mars, and Titan, with its star rings, atmospheric surge, and nourishing oceans, has obviously become a paradise in their hearts. Development of other Jupiter and Saturn satellites. In addition to tourism, the Jupiter system also provides many valuable resources for space exploration. For example, Callisto has a very thick ice layer, and because of its distance from Jupiter, ionizing radiation is also very weak. The development of Callisto began in the early 22nd century, almost in the context of the terraforming of Mars, and with the intermittent phase I projects, Callisto has been quietly providing a large amount of water to Mars. However, large-scale mining on Callisto has severely damaged tourism development here. Unlike Europa, however, Ganymede has extremely thick ice like that of Callisto, so companies have built magnificent exhibition halls and amusement centers in the ice to attract tourists. The Moonlight Ice Palace project, which was started by Firebrand in 2199, has been an industry leader, with the then well-known amusement project Color of Time being held in the Moonlight Ice Palace Amusement Center. The Color of Time was held at the Moonlight Ice Palace Amusement Center. Through the use of specific light and shadow effects in the ice tunnel, visitors on the ice tunnel roller coaster would feel like they were going back in time, and many of them would feel that a part of their past life was still fresh in their minds. In the context of the rise of Mars migration, many new industries have emerged. Space engineers. Spacecraft pilot. In accordance with the provisions of the Public Act on the Peaceful Development and Use of the Solar System, the System Act, concerning the piloting of spacecraft, cargo ships may fly autonomously and unmanned on a predetermined course, with remote tracking and remote control by a pilot. In the case of manned airships, at least one qualified pilot is required for the safety of passengers. With the opening of the Earth-Fire route and other peripheral routes, the demand for manned airships is increasing every year. In addition, the purchase of a private airship is also popular among the rich circles. However, because of the specific training and certification required to pilot a spaceship, many people do not want to spend too much effort to obtain a license to pilot a spaceship, but choose to hire a professional pilot. Space Express Company. UPI's Space Express Company has a large staff of pilots and provides pilot training services. To qualify as a pilot, you must go to the Orbital Transportation Division of the Star Transportation Center, a division of the Bureau of Interplanetary Migration. Basically, all active manned aircraft have identification devices in their pilot units, and only qualified pilots are allowed to start the aircraft. Airship inspectors. The market for airships is growing, and so are the number of private airships, especially between the surface of Mars and the orbit of Mars. The Benny Company. The Benny Company was the first ship repair company, and until the early 23rd century was the largest ship repair company with the most stores and employees. When the industry was in its infancy, the airship mechanics were the people who guided the people in the inspection of airships, and their expertise in electronics, mechanics, propulsion, etc. was very high. With the advancement of technology, airship inspection tools have become so easy to operate that a small airship can be inspected by one person, and the airship inspector no longer refers to the inspection team leader, but to those who operate the inspection machines. Airship pilot. Cargo ships are usually not required to have a pilot, however, the system law requires at least one pilot to monitor and control the ship as necessary during important operations such as takeoff, landing, and orbit change. The pilot is usually replaced at different stages of the same cargo ship's voyage, based on the minimum light second principle, which minimizes the time difference between the pilot and the ship's control. For Earth-Mars cargo routes, only one pilot each for Earth and Mars is usually sufficient. For near-Earth asteroid routes, it is impossible to equip pilots on all asteroid mines, so stations will be set up in some special places. The three largest stations are located at Earth Sun L3, L4, and L5, while the rest of the stations are located on asteroids with rich resources and large cargo volumes. Heavy machinery operator. Although most of the heavy machinery in space is automated, some machines still need human control, especially the large and heavy machinery. In addition, for asteroid mines such as heavy machinery concentration, although automated production has been achieved, but the duty officer must also be in the control room. Real-time monitoring, in case of failure, can be dealt with in a timely manner. Asteroid mining industry at the peak of development, once used a giant excavator. These excavators can carry out automated excavation work, but in some specific details need some remote control operation. In the small manned spaceship really developed before, space heavy machinery operators are mostly in the Earth, Mars, or space station to carry out remote control operation of machinery. The appearance of various types of space machinery also makes the space heavy machinery operator more and more. And later heavy machinery operators, many have been working in the field of machinery. Space print engineer. Since the first manned mission to Mars, 3D printing has gradually become the mainstream direction of mechanical manufacturing in space. The rise of the space printing market has led to a number of lower barrier space occupations, and the market for space printing engineers is growing in demand, with several qualification exams for space printing engineers with different emphases. Space printing is actually a highly automated process, but model design, printer maintenance, and program maintenance require many on-staff personnel. Made in Space. Made in Space is a company that was founded before the manned landing, 2010, and they were the first company to manufacture products directly in space. During the subsequent fire boom, the company's business grew exponentially and became more financially powerful, beginning to overtake many of the larger Earth-based IT companies. Orbital design, planning, and scheduling. With the proliferation of spacecraft, space stations, and asteroid factories, the selection of a suitable orbit for spaceflight takes into account launch windows, fuel consumption, travel time, flight safety, transportation costs, and many other factors, all of which are part of the orbit design, planning, and scheduling process. Space junk removal. The space junk that needs to be cleaned up generally only includes the scrapped spacecraft in Earth orbit and Mars orbit, although there will also be a small amount of space junk on the transfer orbit, but because the interstellar space is so vast, the chance of encountering space junk during the transfer voyage is smaller than the chance of winning the in-planet lottery jackpot. However, the situation around Earth and Mars is far less optimistic, and if the space junk is not cleaned up, the spacecraft in orbit will be threatened. Clear umbrella technology. Clear umbrella technology is a pioneer in the space junk removal industry. The earliest methods of trash removal, such as orbital netting and scavenger capture, were very inefficient and unable to clean up the smaller space junk sizes. Umbrella technology was the first to use high-energy laser directional erosion technology to clean up space junk on a large scale, and the smaller junk quickly vaporized under the effect of laser, while the larger junk became the raw material for space 3D printing factory after recycling. Space rescue. There are several rescue centers in space, and in order to ensure the safety of navigation, the location of rescue centers along the way is generally taken into account when designing and planning the orbit of the spacecraft. Space rescue is a highly paid profession, not because of the high accident rate of space navigation, but because the cost of rescue is too large. From the time a rescue mission is received, to the location of the rescue ship, to the time the ship arrives at the incident and completes the rescue, the cost of a rescue effort can be higher than the cost of a single voyage. Space rescue is generally divided into personnel rescue and cargo rescue, and the cost of rescue is generally borne by the corresponding insurance company. For personnel rescue, the rescue time is the most critical. To get close to the accident ship quickly, a considerable amount of fuel is needed, which is much more than the fuel used for a normal transfer flight. Therefore, the rescue center's ships are equipped with the most powerful engines and sufficient fuel for various rescue missions in different conditions. Space sports. Private spacecraft pilot instructor. Since piloting a spaceship requires a lot of skills and knowledge, it is very difficult and dangerous to learn on your own. A spaceship instructor can accompany you to practice and teach you how to drive. Space fitness instructor. The low gravity of the space environment requires that fitness in space is very different from fitness on the ground, and in order to maintain good health, fitness in space is essential. Space fitness instructors are fitness instructors who specialize in providing fitness advice and guidance for people living in space. Low gravity game development. The new environment of space causes the original game that people like on Earth cannot be carried out normally, so some people began to design new games specifically for space. They are called low-gravity game development experts. Low-gravity fighting. In low gravity, it becomes very difficult to take down a person because without support, the attacker will be pushed in the opposite direction. New fighting techniques are gradually being developed and some people are becoming experts in low-gravity fighting, while others are specializing in low-gravity fighting. Every year, SMMA attracts a large number of spectators, and major companies also compete to invest or advertise. Space diving. Space diving is a very novel space sport for people on Earth. Space diving generally requires a special chamber, and the entire chamber must be covered with a layer of waterproof material. Under weightless conditions, the internal pressure of the water is equal to zero, and the surface tension forms scattered water balls in the chamber. Space diving is to travel back and forth between these water spheres of different sizes, seeking a different experience in the ever-changing water bodies of space. Space racing. Similar to Formula One racing on Earth, racers use a single-person spaceship to participate in a racing event that meets the rules. Space racing is generally conducted near the planet's low orbit, and there is no fixed course, only a start and finish point marked by wireless telecommunication. The race consists of getting from the starting point to the finishing point in the shortest possible time, and the entire process must be driven manually, with the use of automatic navigation systems prohibited. Even though the boats are professional speed boats with enhanced safety for the pilots, it is still a high-risk sport. Spaceball. Most ball sports on the ground cannot be played in space, but thanks to the ingenuity of low-gravity game developers, some popular ball sports have been brought to space, the most popular being not soccer or basketball, but pool in space, spaceball. Spaceball. Like most space sports, spaceball requires a special chamber, usually a sealed chamber with a sphere in the interior and a hole in each of the 6 directions. The rules of the game are similar to those of Earth-based pool, with white balls hitting other colored balls to score points. However, spaceball is much more complicated, as players must be careful not to hit the ball in the chamber, and it is much more difficult to set up the cue. However, compared to other sports, spaceball requires less space and is easier to promote, so naturally, spaceball has become an important activity for people in space to enjoy. Space farming. Low-gravity gardeners. Gardening in low gravity is very different from that on the Earth's surface. Since the distribution of growth factors is not affected by gravity, plants cannot adjust their growth direction according to gravity, resulting in relatively chaotic plant growth. Low-gravity gardening is the use of weightlessness to make plants take on different forms through light and centrifugal force generated by rotation. Skyline Garden Company. The most famous low-gravity gardening work is certainly the Crystal Heart by Heaven Garden. In this work, the plant's nutrient solution is suspended in a weightless environment, and the white starry sky grows outward with the nutrient solution as the center, eventually forming a 3-dimensional heart shape. The crystal heart is sealed and fixed in glass and shipped back to Earth for sale. The crystal hearts were very popular with the people of Earth, but because of the low production volume, a small low-gravity gardening piece was expensive. Since then, the people of Earth have begun to understand the profession of low-gravity gardener. The sky garden has naturally become a sanctuary in the hearts of women and a nightmare in the hearts of men. Plant and animal breeder. During the construction phase of the Mars outpost, the plant and animal breeder is a very important job. Due to the limited supply from Earth and the restricted view of the launch window, the cultivation of plants and animals on Mars becomes an important job that affects the quality of life and even the safety of the builders. Unlike researchers engaged in biotechnology development such as genetic modification, plant and animal breeders do not require a high level of scientific ability, always take care of what they are breeding is all they do. Of course, this also requires them to understand the impact of the Martian environment on plant and animal growth, and when necessary, the breeders will also receive technical guidance from experts. Cell culture workers. In space, animal breeding is particularly difficult due to the effects of weightlessness, which, combined with space limitations, makes large-scale breeding virtually impossible. For plants, the weightless environment also affects their growth, and the yield is therefore reduced. However, the long-term stationed in the space station astronauts are not satisfied with 3 meals a day canned food. In order to let them also eat fresh meat, cell culture crew was also stationed in the space station. Although the production of food through cell culture technology has been quite mature, and compared to the ground culture and cultivation, cell culture production costs are cheaper, more conducive to large-scale promotion. However, the production of food through cell culture is opposed by the majority of people on Earth due to their natural aversion to this artificial food. This technology, which is scorned on Earth, has become a boon to astronauts. In order to make their lives more comfortable in space, most astronauts are able to accept the consumption of cultured food. Even some astronauts return to Mars at the end of the mission. The cultivated food cannot forget, but find the real meat tasteless. Gradually, cultured food is becoming popular on Mars, and there is a growing demand for cell cultures on the red planet. Space medical. Medical examiners. In order to prevent the invasion of foreign bacteria and viruses, from other places back to Mars or Earth, need to go through a strict medical examination before passing through customs. This is the work of customs medical examiners. In addition, because of the specific physical requirements of space flight, medical examiners will check the crew of the upcoming flight to ensure flight safety. Space nurses. Due to the disparity in medical conditions between Mars and Earth, some special patients or disabled personnel need to be transferred to Earth for further treatment. However, the length of the transfer voyage is usually very long, and to get patients through the transfer period smoothly requires not only a special medical ship, but also a professional space nurse to take care of the patient's diet and living. It is in this demand that space nurses emerge. In addition, some wealthy people also hire personal space nurses to take care of their own lives on board for their own health. Dietitian. Prolonged spaceflight can have adverse effects on the human body. Under low gravity conditions, the human body is prone to calcium loss, resulting in osteoporosis and muscle weakness. In addition to daily exercise, a reasonable nutritional supplement is also essential. The nutritionist and the space cook cooperate with each other to ensure the normal nutrition supply of passengers on board. In addition, the dietitian also serves as the ship's doctor, so if a passenger becomes unwell during the voyage, a dietitian can usually solve the problem. If the situation is more serious, a professional physician will be needed to assist remotely. Psychological counselors. Space work is mostly solitary and monotonous, and requires frequent travel between different environments, different gravity, radiation, air pressure, etc., and many people suffer from psychological disorders, often with manifestations different from those of previous mental illnesses. Custodians. Mars does not have a global magnetic field like Earth, but only a few fragmented and weak magnetic fields, which makes the radiation situation on Mars even more severe. During the construction phase of the Mars outposts, the Bureau of Interplanetary Migration prohibited volunteers from having children on Mars, supposedly because of the possible threat of radiation to pregnant women and fetuses. The first nursery station on Mars was completed during the latter part of the construction of the first colony. The nursery was equipped with advanced radiation protection facilities and better living conditions. When pregnancy is detected, the pregnant woman will be transferred to the nursery where she will be cared for by professional caregivers. After the birth of the newborn, the caregivers will also be responsible for the care of the baby. Space crimes. Space smugglers. With the development of the space industry, the resources and products of different regions of the solar system are gradually becoming different. Space smugglers use illegal means and cheap transportation methods to buy at low prices and sell at high prices, extracting high profits. In addition to smugglers acting alone, there are many smugglers who have joined together to form the so-called Smugglers Alliance. They protect each other, share part of the benefits, and even use some empty shell companies to make huge profits. Willowwood industry. There is a famous smuggling case of cryptomeria in history, involving more than 200 smuggling airships. Cryptomeria wood was ostensibly engaged in the wood products industry, with wooden luxury goods being the company's largest legitimate source of income. In order to reap huge profits, Cryptomeria wood used the transportation chain of wooden luxury goods from space to smuggle various products, which even involved large transactions of hallucinogens. It was only when the media finally revealed these illegal smuggling activities that they came into the public eye, and the industry was finally punished as it should be. Space smuggling has gradually become a very large industrial chain. Smugglers use tools, spaceships, forged documents, etc., all with specialized suppliers. Space pirates. Since most regular ships have a defined route, this allows space bandits to steal or rob the ship's cargo at the right place. Black Vortex. There is a legend about the Black Vortex among regular Earth and Mars pilots. When a ship flew to some remote area, some ships with black swirling patterns suddenly appeared, and then the cargo was inexplicably lost, and the black swirling markings were left on the inside of the cargo bay. Legend has it that a pilot witnessed thieves in the cargo bay who were dropping off cargo with a black swirl logo on their suits. These space thieves not only steal, but also rob and kill. The ships they stole did not leave any images or audio records, and the logging systems of these ships were invariably out of order. Because of these legendary reasons, the black vortex became the representative symbol of space bandits. It has been uncertain whether the black vortex is a single organization or a common symbol for many organizations. Of course, some of the pilots who experienced the theft said that it was not a black vortex, but a black lollipop look-alike. Space service. Space cooks. Low gravity and low pressure will affect the human sense of smell and taste. Space cooks use special seasonings and ingredients, combined with specific methods to create food suitable for eating in space, while ordinary chefs use Earth-based cooking methods to make food that tastes bland and tasteless in space. Space cooks undoubtedly save those who live in this environment for a long time. Mars/space funerals. Many people believe that after death, space is the most suitable place to go. Therefore, space funeral services were once popular. In addition, many people also state in their wills their wish to be buried on Mars. There are many different kinds of Mars/space funeral services, including space cemetery, space rafting, Mars cemetery, Mars alpine burial, orbital tombstone, and so on. Space funeral is a high-income industry, and this has attracted many investment companies to invest in corresponding ventures. Outer Heaven Incorporated. Outer Heaven is a famous company that provides space funeral services. The company operates several cemeteries located in space orbit, on Mars, planetary satellites, and asteroids. Some of the more famous ones include 2 huge cemeteries on the 4th and 5th Lagrangian points, as well as asteroid cemeteries. They offer a single space cemetery for exclusive use of an asteroid, but at a high service cost. Space Special Services. Space Special Services are mainly space-based services, which are legal only in designated areas, but there are many illegal operations, which are difficult to be fully investigated because of the good mobility. The special services industry is mainly managed by the United Nations Space Prostitution Information Office, but the actual management is performed by personnel from other agencies or companies hired by the United Nations. Space tourism. Space tour guides. There are 2 types of space guides. One is the attraction guide hired by the attraction. This kind of guide has a low entry barrier and low salary. In addition to the knowledge and skills required of a tour guide, these guides usually have a very advanced spaceship pilot's license and even a variety of first aid and other medical skills and combat skills, and are usually hired by the rich and famous to provide them with tour guide services. Tourist attraction explorers. With many locations undeveloped and uninhabited, and with emerging aircraft making transportation costs low, tour companies are looking for potential tourist attractions. It is against this backdrop that tourist attraction prospectors have been created. Explorers are required to follow a plan to explore an area, identify potential tourist attractions, and write an assessment report. The assessment report describes in detail the characteristics of the potential attraction, the possible forms of development and feasibility, and the assessment of potential visitors. This shows the flexibility of thinking required in this industry. Space business. Auctioneer of space antique objects. Many Earthlings like to collect antique rocks and old Martian probes from Mars, and other antiques with Martian meaning. Martian antique auctioneers will value these items and hold auctions according to legal and reasonable procedures. Space Sphere, Incorporated. Space Sphere, the first company to auction space objects, has a number of top auctioneers. But before that, there were already many individuals in the business. In particular, they were selling antique Martian objects to certain collectors on Earth. Space art. Space painters. In the space age, new schools of painting are emerging rapidly, such as space nihilism and space realism, which are becoming more and more popular. Unlike the space paintings before the space age, the paintings made by space painters were not only for painting space, but also for expressing the spirit of space. Space painters often took spacecraft to experience the flavor of space and then expressed the inspiration they gained from space in their works. Space realism paintings have been among the most popular paintings, depicting realistic scenes from space and other celestial bodies. At the beginning of the migration to Mars, space nihilism painting reached a peak. Some of these painters used various techniques and technical aids to express the confusion of mankind in the space age. Most of the works of these painters have a strong philosophical meaning, trying to express that space is only a symbol of nothingness, and that human beings are only a subtle and invisible part of this symbol. The vastness of space reinforces the nihilistic philosophy of the meaninglessness of life and even humanity in the minds of many space painters. Space musicians. Punk music and death metal make up a large part of the space-themed music. Space music began with the development of metal music, much of which dealt with the emptiness of space, violent death, exploding spacecraft, and so on. But later on, space punk gradually became dominant in the pop music scene, and similar to the punk culture of the 20th century, space punk music was also new and different from the traditional boundaries. However, space punk music did not last very long. After that, space music entered a state of blossoming. There is a high percentage of freelance musicians in the space music profession, who never signed with any company and insisted on producing independently. Of course, most of them are still professional bands, professional songwriters, and professional lyricists. Hit You Hard is a famous space metal band that doesn't sound like a death metal band by name, but their music is close enough to death metal. However, the band's lead singer went to prison for murder, throwing a waiter through an airlock and into space, ending the band's dominance in space metal. Space punk music has not been dominated by one band, and the charts are constantly being refreshed by new bands. However, Down the Spaceship has to be mentioned as a space punk band that was born in a spaceship repair store. All of the members are spaceship inspectors, and their songs often use a lot of spaceship repair vocabulary, making them unique. There is no new major record label in the history of space music. In the field of professional music, it was still the pre-space age companies that dominated the development of popular music. However, they have been impacted by many independent musicians. Other diplomats. The Star Migration Agency has offices in many parts of the planet, so diplomatic personnel are needed to communicate with Earth. These diplomats are treated with the same respect and protection as ambassadors between different nations on Earth. Space security. The emergence of space crime has necessitated the establishment of space security personnel to maintain security in densely populated space stations, development areas, and other areas with dense flight paths. Space lawyers. All human activities in outer space should be governed by the public law for the peaceful development and use of the solar system. The special nature of space crime requires a broader knowledge of lawyers in the field, so space lawyers are becoming a new profession. Archivist. Almost all organizations have their own archives, which are used to organize and record organization-related files. Because of the extensive cooperation in space, it takes a lot of communication between archivists to produce a quality and complete file.